All right. 9.7, we're solving systems of equations using algebra. So algebraically. And then the last part says, interpret the meaning of the solutions of a system of equations. Really what we're going to do when we get done with it is we will be able to either have an ordered pair, so an x value and a y value, just like you did with graphing. We will have the option for infinite solutions, or we'll have the option for no solution. Okay. So up until this point, doing the algebra stuff that we have done substitution before. Who remembers what substitution is? I'm not going to put you on the spot. Who here remembers doing substitution? Just give me a little thumb or a little hand up. Okay. All right. Well, substitution, for those people who don't remember, substitution is when we can put all the information in for a specific value. Okay. So like right here, I've got two problems. I've got this one that says y equals -5. And then I have this other one that says y equals x plus 4. What I can do for a problem like this is I can make these ones, I can plug in the number. So for this problem, it says every time I see the letter y, it's going to equal 5. That's what that top one says. Now this bottom one, I have a big, long equation here, not super long. But instead of saying y equals x plus 4, what I can do is I can substitute this value in. I'm going to highlight it here. I can take this value here, and whenever I see the y, I can put it in that spot. Meaning, instead of saying y equals x plus 4, I can plug in that value and say 5 equals x plus 4. So I took this value of y, where it said y equals this, and then I just plugged this value into the other one. Do you see how I was able to put that one in there? Yeah. Okay, now I've got 5 equals x plus 4. Now what I'm going to do is I'm going to solve just for that variable. So just like what we did before, I'm going to put a little line straight down the middle there. I want to get x all by itself. So I want to subtract 4 to both sides. I have a positive 1 equals x. So far, I feel pretty good. I know what x equals. Do I know what y equals? What's y equal? Perfect. Yeah, you guys got it. So I've got this one here. X equals this. Y equals this. I have all the information I need in order to put together an ordered pair. Remember, an ordered pair is my x value and then my y value. So what I'm going to do is I'm going to take whatever I had for that x value, which was 1. My y value was going to be the 5. So my solution to this first problem where it says y equals 5 and then y equals x plus 4, my solution is going to be at 1, 5. I'm going to show you right now how I could have done this one using the graphing portion of it. You're not going to graph, but I'm going to show you how it could have worked out. Whoops. Let me get a graph on there. View, some graph paper. Fantastic. All right, I'm going to look at my very first one. That first one that was up there that said y equaled 5. And then the other one was y equals x plus 4. So for that top one, my m value, my slope was 0. I didn't have one at all. My b value is going to be at a positive 5. For this one, the second one, my m value My slope was going to be 1 over 1. My b value is going to be at positive 4. Again, you don't have to do this. I'm just going to show you how this works out for this very first one. And after this, I'm not going to graph them again. But I want to show you how it works out. So I've got my graph starting here-ish. I'm going to go here because I don't need too much on that side. So for my very first one, my blue one, I need to go to 5. 1, 2, 3, 4, 5. And then my slope is 0, so it's not going to go up or down at all. It just means that that line's going to go forever that way. My green one, I'm going to go to B is 4. My slope is going to be up 1 over 1, up 1 over 1. That graph looked like this, kind of. I'll pretend like it's better. The spot where they both came together was right there. If I want to count that over, that's going to be at 1, comma, 5. Do you see how, if I were to graph it and solving it algebraically, it's the exact same thing? Yes. Yeah, it's the exact same solution. The great news is I didn't have to be nearly as artistic. I didn't have to draw my lines. I didn't have to use up half a sheet of paper just to make one picture. The algebraic way of doing things, again, you don't always have to do the algebraic way, but the algebraic way of doing things allows you to solve it without having to draw a picture, without having to have that visual representation. Okay? Also, if you have some bigger numbers, it's a lot easier to plug things in. Okay, I'm going to go on to example number 2. And I shall zoom in. All right, so I've got y equals 7 minus x, and then I have the x minus 3. So those are the two equations I have to work with. We're going to substitute. So looking at those numbers, those two equations, which one do you think will be easier to substitute into the other one?
Substitute 3 and then y equals 7 minus x.
Yes, I love it. And the reason I'm going to go exactly with what you said. How this one, this letter, only had one thing behind it. I only have to substitute one thing. I will get to a harder one later. But yeah, I'm just going to take whatever I see this x, I'm going to substitute in this number 3, just like Austin said. Fantastic. And what I want you to do every time you do the substitution, giving you a super giant hint, rewrite the problem. Don't try to do it in your head. Rewrite the problem. So I've got y equals 7 minus, because that's exactly what it said, 7 minus. And now I'm going to substitute in that value for x. The value for x was a 3. Put it in parentheses. Do whatever you need to make sure that whatever this value is goes in exactly the same as the one before it. I didn't get rid of this minus sign. If there was a negative sign, I wouldn't get rid of that. I have to write exactly what was there. Okay, what's 7 minus 3?
4.
Fantastic. Do I have my x value?
Yes.
Do I have a y value?
Yes.
Can I put together my ordered pair?
Yes.
What is it?
I guess everything is
What is it? Not -3. So again, my x value is up here. I'm going to write exactly what that one said. You're right. When I plugged it in, it turned into a -3. But I only want to know what it was before I did that substitution. Perfect. 3, 4. In that order, 3, 4. Feeling okay?
Yes.
Okay, I'm going to have you guys talk me through this one. I've got x equals y plus 4, and then x equals -3. Gabriel, what are you thinking?
4 equals -3. But
Huh?
4 were the x's.
Why?
Why you put the negative?
So the reason I can't, so I'm gonna go with kind of what you're saying. I can't put this 4 here because if this had x equals 4, then I could put that there.
Oh.
But it's x equals this whole thing, and x equals this whole thing. How can I rewrite this problem? Austin, what do you got?
-3 equals y plus 4.
Fantastic. I'm going to use a highlighter just to show off what you did. -3 equals y plus 4. Because what Austin said is he said x equaled this. And he said, all right, well, if that's the case, I'm going to put this into this spot. He substituted, at least that's the way I took it. You substituted this value for x, and you just put it right in front. That's how we got -3 equaled y plus 4. All right, somebody help me out. Again, this is the one where you guys tell me exactly what to do. What do I do next? Hector?
Add 3 to both sides.
Okay. So I'm going to draw this line just so I can keep them separated. Add 3 to both sides. Now I got 0 equals y plus 7. Am I done? Okay, subtract 7 from both sides. -7, -7. I get -7 equals y. Am I done there? Okay. Come on, you. Oops. Okay, what do I got next?
Right here.
Do I have to do any more algebra stuff?
No, you have to your order pair.
I just have to write my ordered pair. Fantastic. What do you got? Okay. Yep. So I got -3, -7. Great catch. My ordered pair for that one is going to be, I'm going to erase this so you can see the number better. My ordered pair is going to be -3, comma, -7. And you caught that I needed to keep the negative sign on both sides. So fantastic. That's my ordered pair for that one. Give me thumbs up, thumbs down. What are you feeling? All right. You guys do this one. On your own, I'm walking by. I'm going to check it out. Is this surprising? It's like the same pattern I do every single day. All right, I'll turn it up a little so you can see what you're writing. But the two equations I have is y equals 7. And the other equation is y equals 2x minus 5.
something imaginary.
We got it.
Here, check it. That's why it's up. So we have the X by itself. Touch before it's doing the hip divided by 2.
I already gave you that one time.
So it should be 6.
She said if she does 8
6
every day,
X.
then she'll even it out to 20.
So it's shorter.
All right, you guys all work through it. Again, you plug that stuff in. You had 7 equaled 2x minus 5. You went through, you did all the math. I'm going to do the really short version here and solve it quick. Should have had x equals 6, y equaled 7. With the ordered pair, when you're done, make sure it goes in the x first, then the y value second. So you should have had 6, 7. Okay, I'm going to show you I'm going to say trickier one. That's going to be the last one we do for the day. So looking at these two equations, I've got this 2x. Actually, I'm going to enter in here so I can get some extra space in between them. I've got this 2x minus 3y equals negative 10. And then I've got 1 equals 4x plus y. Out of both of these problems, which one looks like it'd be the easiest to get a single letter all by itself? The top equation or the bottom equation?
The top.
The top one? So if we did the top one, we'd have to add or subtract to move it to the other side. And then we'd have to divide something to get the letter all by itself. Do we have, really what I'm looking for is I'm looking for a lonely letter. I know it sounds weird that I explain it that way. I'm looking for a lonely letter that doesn't have any numbers in front of it. The bottom one, yeah. So I've got this y. This y is kind of this lonely letter. It's just the letter y all by itself. So what I can do is I can rearrange this bottom one to get that y all by itself. So what I'll do, I'm going to subtract 4x from both sides, minus 4x to both sides, and I get negative 4x plus 1 equals y. Yep, because there was this 1 in front of it. So I
thought it was like number 1 the problem.
Yep, no, sorry. Okay, so I got negative 4 plus 1 equals y. Okay, I've got that lonely letter by itself. I got that y equaling something. What I can do, and here's where it kind of breaks people's brains a little bit, just little breaks, is this equation up here. I'm going to rewrite that with this whole entire thing whenever I see the letter y. So I get 2x minus 3, and then instead of writing y, I'm going to write that whole entire thing, minus 4x plus 1 equals negative 10. I will solve the rest of this tomorrow, but when I get to substituting, I substitute that whole value in.